Good morning, class. So for today's video, we will continue our discussion on the method of joints for this example for structural analysis. Alright, so we will solve the reactions at A again for this video, but in our last class, it's already been solved. So just in case you missed it, I'm gonna do it again. For this problem, we are asked to find the forces at AB, member AB, member AC, and then BC and BD. Okay, so the first thing that we have to do is to solve for RA. Why is that? Because for method of joints, we should only have two unknowns at a time. So the only way to solve for two unknowns at a time is to get force reaction A, because we cannot start at B because there will be 1, 2, 3 unknowns, and for C that's 1, 2, 3, 4 unknowns. So we can't do method of joints there. But we will eventually get there once we solve each segment, or each member bit by bit. Alright, so how do we solve for RA? So we could take a moment at, maybe we call this Z. So you take a moment at Z equal to 0. So from there, your equation clockwise equal to counterclockwise as always. So the forces that cause clockwise rotation is RA, and then don't forget the distance. So this is 3 meters, and then 3 meters. So that's 3, 6 times 9. Okay? For counterclockwise, it's 104 and 200. 104 here is 3 meters, and then this one's half, so that's 1.5 meters. So 104 times distance 3, 6, 7.5 plus 200 times 3 and then 6. Alright, so now we can solve RA. Of course, you just divide both sides by 104. Divide both sides by 9. Now you will get 104 times 7.5 plus 200 times 6 divided by 9. So that is 220 kilonewtons. Okay, so now we can proceed to doing our method of joints. So we could say at joint A, so this is your joint A. The forces that occurs at joint A is of course RA, which is 220 kilonewtons, and your other members, where in this case we're not quite sure what direction the arrow goes, right? But if you look at it, this is governed by the equilibrium equations. You have to sum up forces vertical, it has to equal 0. You also have to sum up forces horizontal, and that also equals to 0. So in this case, what direction for force AB would allow for an equilibrium? So in this case, since we are sure that RA is going up, FAB then must be going down. So, and also since it's also going to the right, to the left, your AC must be going to the right. Okay? So as to create these two conditions valid. Alright? So, how do you make your equation for this one? So I'll just take this for example. So forces going up is equal to forces going down. So it's 220 equal to force going down. FAB. Wait, we cannot just put FAB because it is diagonal. It has component forces. So it has this component force and that component force. It is FABY, FABX. So FABY, right? FABY. So, and then FABY is, so we need to get the angle of this. What is the angle of that? So theta is the arctangent of 1.5 by 1.5. So essentially it's 45 degrees. You check it in your calculators. Arctan 1.5 by 1.5. That is 45 degrees. Okay, so 220. Now that's FAB. Now we're going to use sine because this is your angle and then the opposite, so we could just translate it here and that should be the opposite of the angle. So we will use sine. Sine 45 degrees. Now you can solve for FAB. FAB then is 220 divided by sine 45. We will get, so we divide both sides by 1 over sine 45. So you will get 311.1226, or you can just write 1.13. Okay, so that's your answer for this one. Next, summation forces horizontal. So actually you could do the other way around. You could start with X. Either way is fine. Just so happened for this method I did try the Fy first. So Fx, that means forces to the right, going to the right, that's FAC, is equal to force going to the left, that's FABX. And what is FABX? FABX is the cosine of FAB. Alright, so with that we can now get the answer for FAC by dividing. So this one, we already know this one is 311.13. So we just use that value, cosine 45. Now we also get 220 kilonewtons. Don't forget the units. Alright, there you have it. So force AB solved, that's 311.13, and FAC also solved. Where's AC? Here. That's 220 kilonewtons. Next, so we are asked to solve for also BC and BD. So I guess in this case we'll need to do method of joints at B. Alright? So for B, a joint B. Alright, so what forces are there in joint B? So we have the given load 104 kilonewtons. We also have some force here, also here and there, right? So this is your FAB, and this is your FBC. Also, this is your FBB. Okay, so I forgot to include here the nature of the force. So it's either compression or tension. So FAB, in this case, since the arrow is pointing towards the joint, that is compression. Okay? And that means since FAB is compression, the arrow for joint B for FAB should also be pointing to point B to represent compression. So FAB is equal to 311.30. Okay, so that's one. Now, this one, how about this? The arrow is going away from the joint A, so meaning this is tension. So these two markings are very much important. This will be included when I check your work later on. So it has to be one check and another check, one check and another check. Okay? Also, I'll be giving points for these as well, so make sure you draw your force diagram. Okay, so here we know that it's compression. So what about FBD and FBC? How do we know if it's compression or tension? Well, at this point, you don't have enough experience to really say right away, but what you can do here is to assume a force, if it's a compression or tension, and then later on when we're trying to solve, we will find that we get a negative value. That means we got the sign wrong, or like we got the direction wrong. So meaning if you solve and then you assume that it's compression and then it comes out negative, that means it's tension, and vice versa. If you assume it to be tension and then you get a negative answer eventually, so that means that should be compression. And we'll see us along the way, right? So joint B, summation forces. So maybe we could assume this one as tension, compression, and this one as tension. You know, but you can do it the other way around. Just try to explore. So Fy equals 0. So force is going up. So the force is going down. So this is very important because now we also need angles as well. But lucky for us, it's symmetric. So we can already say that the angle we solved earlier is still applicable for this. Alright, so when you do your summation forces y, we get this one, FABX, FABY, sorry. Now, and then I guess that's the only force going up, assumed. And then this one, 104 going down, and FBC, Y. FABY, FBC, Y. Okay. So now we gotta express these guys to FAB by using sign. So that becomes FAB sine 45 equal to 104 plus FBC sine 45. Okay, so just leave this as it is because, oh wait, we could solve actually FBC because FAB we already know the value, which is 311. So if we try to substitute that 311.30. We can now solve for FBC. FBC is equal to, so what you do, transfer it there, and then you divide both sides by sine 45. So FBC, then you get sine 45 minus 104. 311.13 sine 45 minus 104, and then divided by sine 45. So you'll get 164.05. Okay, so that's your FBC. Is that positive? Since it's positive, that means we made the correct assumption. FBC is tension. Now, summation Fx equal to 0. So the forces that are going horizontal are this one, the component FABX to the right, and then also FBCX, and then the force going to the left is just FBD is equal to FBD. Alright, so FABX, we can solve that by using FAB cosine 45, and then FBCX, we got that by FBC cosine 45, and then lastly equal to FBD. And since it's already horizontal, no trigonometric function needed. So remember that we already solved FAB earlier. That's 311.30, and FBC has already been solved just now. That's 164.05. So if you plug those in your calculators, you will get FBD. So that is 311.30 cosine 45 plus 164.05 cosine 45. We will get 336 kilonewtons, and that is in FBD compression. Alright, so now you're able to solve forces FAB. In this portion, that's compression. FAC, this part is under tension. FBC is under tension, and FBD is under compression. Alright, I hope that came out clear. If you have any questions, don't hesitate to reach out and send me a message. Thank you.